All right, Six Sigma, Chapter 5, Part 2, picking up where I left off yesterday on page 70. Right here, if you're trying to follow along. When you're ready, defining a Six Sigma project. Remember, when dealing with a project, you get into the nuts and bolts of Six Sigma. Doing this step right is well worth your time because 50% of your project success depends on how well it is defined. Different people can be part of defining a potential project, including the following. See Chapter 4 for the lowdown on these roles. Champions, belts, process leaders, functional managers, or process owners. Note, any employee can suggest a Six Sigma improvement project, but have one of the people in this list consider and sponsor the project. Warning, the most common mistakes people make in defining a potential project are making the scope of the project too broad, solving world hunger or boiling the ocean. Symptoms include considering too many whys, outputs, for improvement. See Chapter 3 for more on what why means. Multiple goals, numerous process owners, and multiple departments. Picking a problem that's too easy to solve with the Six Sigma project. Selecting a problem for which the solution is known or for which a separate specific solution is mandated. Defining a just do it solution where no formal project and problem analysis is required, and trying to make a problem out of a management issue. In the following sections, we provide the steps for defining a project and selecting the key outcomes. We also help you determine the magnitude of the problem and whether forging ahead with a Six Sigma project for that problem is worth the time and effort. Following the steps of the project definition process. To ensure that a project is well defined, go through a specified sequence of events. Generally, you can expect to perform the following 8 specific steps in this process. 1. Determine the why. What specifically needs to be improved? 2. Identify the associated processes and their physical locations. 3. Determine the baseline performance for each why chosen. 4. Identify the cost and impact of the problem. 5. Write a problem statement. 6. Write the objective statement. 7. Identify and recruit candidates for the project team. And 8. Obtain approvals and launch. These steps are a combination of gathering data and organizing that data into a well-articulated project. Having a worksheet similar to Figure 5-4 can guide you through this process. This is Figure 5-4. I'm going to go ahead and not read through that. All right. Identifying the significant why. So you know you want to improve the performance of some process. But how do you figure out which characteristics or outputs of the process need to be improved? You have to identify which process output variables, whys, need improvement to solve the business problem. See Figure 5-5 for an illustration of this process. The whys in need of improvement must be easily identifiable and quantifiable. Figure 5-5, selecting a process output for improvement. This is Figure 5-5. It's kind of simple. There we go. That's in focus. Okay. Warning. If more than 2 whys exist, your project is quite likely too large in scope. You may have to break the project into 2 or more projects to be successful. You probably now have to get a better sense of the process steps that are involved in the performance of your why. Doing so allows you to better understand who will be involved in the project and its scope and complexity. At this point, you need a macro process map, which concerns the high-level flow that generates the output of interest. The good news is that Six Sigma practitioners use several software tools such as Visio, iGraphics, and Aris to ease the drawing of these maps. Such a map shows the full scope of the process and includes all major areas being affected. Figure 5-6 is an example of a pizza restaurant that is taking excess time to make pizzas. The macro process map illustrates the major steps in making the pizza. It's my favorite part of the book so far. Fucking beautiful. All right. Understanding how bad it actually is. You may already have a sense of the magnitude of the problem you want to solve, but that's not enough. Under Six Sigma methodology, you must be able to express the magnitude of the problem, defect level, in some unit of measure. For example, hours, inches, percent late, and so on. Tip: at this phase of your improvement effort, you may not have abundant and accurate data. Although having data of high integrity to quantify the severity of your problem is handy, don't be discouraged if your data isn't perfect at this time. Because you significantly improve the amount and integrity of your data in the measure phase, plan to update the quality of your data at that time. Improving your data is essential because you have to demonstrate your current performance, the baseline, your desired performance, the objective, and monitor the actual data resulting from your project. The comparison of this data is demonstrated in a time series chart, a graphical method employed by Six Sigma practitioners to track the progress of improvement. See Figure 5-7. In this case, the figure tracks the number of pizzas that exceeded the make time established by the restaurant in order to meet customer demands. Warning: verify that your data is long-term, not short-term, when estimating the baseline performance. Short-term data is a snapshot of what's happening and can mislead you. It also doesn't represent all the potential sources of variation that contribute to your problem over the long term, such as seasonal effects. This is Figure 5-7, like pizza making times chart. Remember, knowing the baseline level of performance allows you to calculate the potential financial benefits when you target a level of performance. Deciding whether a project is worthwhile. You've done well if you've gotten to this point. You've identified what needs to be improved, you know which processes are involved in creating your problem, and you've determined your current level of performance. You also may have a good estimate of how much this problem is costing you. After you set the targeted level of improvement, you can then determine the financial benefit of doing the project and decide whether the project is worth your time. The Six Sigma effort is often aimed at cost reductions by eliminating waste, scrap, inefficiencies, excess materials, rework, and so on, that are increasing costs but not adding value. As a general rule, you want all your Six Sigma projects to produce a financial benefit, either directly or indirectly, through cost reductions, revenue growth, balance sheet improvements, or accomplishing strategic goals. Look for a savings category for each Six Sigma project: hard, soft, or potential. We define these three categories as the following. Hard savings reduce expenses and result in a financial improvement. Soft savings are financial benefits that may occur as a result of a Six Sigma project, but aren't accountable as a direct result of the project. Soft savings are calculated by using a rational assessment of the expected benefits and a probability analysis of their likelihood. For example, because of a Six Sigma project, your customers may become more satisfied and place more orders. Because many factors affect order rates, you can't necessarily calculate a change caused by the project, but you just know the project helped. Because these changes aren't traceable directly to the project, they're considered soft savings. And potential savings. Potential savings are a form of hard savings, but require some action or decision to be realized. An example is a project that optimizes the design of an existing product. Until the redesign is implemented, the savings are only potential. As a tip, generally speaking, cost improvements come from reductions in labor, inventory, material, cost of money, scrap, excess equipment, space, and so on. Cost avoidance isn't an appropriate metric for determining Six Sigma savings. If a process has been improved, you can't make a projection into the future about what may have happened if the project hadn't been done. The vast majority of Six Sigma projects are straightforward reductions of cost resulting in hard savings. A good way to estimate the potential value of a project is to imagine how much you could save if the problem was completely eliminated. Be careful not to make generalizations about the average value of a black belt, green belt, or yellow belt project. Projects have a broad distribution of returns. Small projects can escalate, while high-value projects may never reach their potential.